The Voyager 1 spacecraft has detected a strange cosmic hum in interstellar space. This faint monotone hum has been found at a distance of more than 20 billion kilometers from the Earth. Voyager 1 is the farthest artificial object in space. The two Voyager spacecraft were launched in 1977, to take advantage of a rare planetary alignment that occurs every 176 years. It made it possible for us to explore all the four gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. In 1979, just 1.5 years after its launch, Voyager 1 reached Jupiter. It sent back the pictures of the moons of the planet. The spacecraft took pictures of Jupiter every 96 seconds for 100 hours, to generate a color time-lapse movie to depict 10 rotations of Jupiter. After 20 months of exploring Jupiter, Voyager 1 headed towards its next target, Saturn. It became the second spacecraft to visit the ring planet. NASA decided to study Titan, the largest moon of Saturn. Because of that, the spacecraft had to change its planned trajectory and hence, it could not explore Uranus and Neptune. Using Saturn as a gravitational slingshot, Voyager 1 increased its speed to exit the solar system. In 1990, at a distance of 4 billion miles, the probe captured this picture of the Earth. Known as the pale blue dot, it was one of the last pictures taken by Voyager 1 before its camera was shut down to save power. In 2012, Voyager 1 became the first spacecraft to exit the heliosphere and enter interstellar space. Traveling at about 17 kilometers per second, Voyager 1 is still sending back data. Since it is so far away, even radio transmissions take 21 hours to get there. The probe's latest discovery has questioned our perception of the emptiness of the deep space out there. Voyager 1 has detected a steady hum of plasma waves in interstellar space, at a low frequency of 3 kHz. Also called the fourth state of matter, plasma is the most abundant state in the universe. Stars are magnetized balls of plasma. It is a hot and ionized gas, composed of electrons stripped away from their parent atoms. The movement of electrons in plasma leads to thermally excited plasma oscillations. Thanks to its plasma wave system, the probe is well equipped to measure plasma vibrations in the interstellar medium. Since 2012, Voyager 1 has detected 8 distinct plasma oscillation events, ranging in length from a couple of days to a full year. They are mainly caused by instabilities in the motions of electrons, as they interact with shock waves generated by the Sun. However, in 2017, the spacecraft began to detect a weak, yet steady and persistent plasma signature outside of these energetic events. This newly detected signal is strange because it is narrower than the plasma oscillation events, and has held itself steady at about 3 kHz. Another weird thing about this signal is that it has persisted for nearly 3 years, which is the most prolonged continuous plasma signal, recorded by Voyager 1 so far. In these 3 years, the spacecraft has traveled more than 1 billion miles, but the faint hum hasn't changed at all. These types of vibrations mainly originate in the absence of any coronal mass ejections from the Sun. This means that researchers can now use Voyager 1 to measure the frequency of these vibrations and the plasma density whenever they want, even in regions where there is no Sun's influence. A deep analysis of this hum will help us better understand the interaction between the interstellar medium and the solar wind. Earlier, Voyager 2 had reported an increase in electron density, just on the other side of the heliopause. So knowing the pattern of how the density is changing, can also help figure out the reason behind it. But on the darker side, our farthest spacecraft is running out of power. Its power source may not be able to keep the instruments operating after 2025. Still, this detection has raised a hope that even in a few of its remaining years, Voyager 1 is bound to surprise us with its capabilities by exploring the deep corners of the unknown space.